My name is Ali. This is my computer science capstone project, software architecture. My project was using machine learning to enhance images of food. What is happening here is that the user is inputting some images and the software is outputting better images. The software architecture is the user image goes to the ranking module, which is a convolutional neural network that decides whether an image is graded as good or bad. The top 5 images are passed onto the food detection module that ask for human input to detect where the dish is located in the image. The 5 images, together with their locations, are passed to the food enhancement module, where the image altering module is applying position transformations and color transformations that are intended to make the image look better. 300 images after each iteration are passed back to the ranking module, which picks the top 5 processes and passes them back to the image altering module. This is repeated until all the image processing combinations are exhausted, and at the end, the ranking module picks the top 5 images and returns them to the user. The two things that did not make it into the final version of the software is that the food detection module was supposed to use artificial intelligence to detect the use of the food instead of human input, and that the position transformations module was initially supposed to use photographical heuristics to decide on how to position the food. The main script is called getGreatImages.py, and I am running it in debug mode. In debug mode, it will execute each image processing algorithm just once, and as an output, it will write one image per color transformation algorithm into that folder, just so you can see how it works. Now let's look at out images. The images are saved here. If this were not debug mode, there would be 5 images here, one per input image, and it would be the best version of the input image for each input image. Here I have two pre-computed values for an actual run. It took around 5 hours to do this one single image. This is the input image, this is the output image. As you can see that there have been both positional transformations and color transformations. So you might wonder, is the image on the left actually better? And yes, according to our AI, the output image is 7.3% better. And not only that, the output image is 99.8% good. That is almost perfect. However, this doesn't actually mean that the image is perfect, obviously, but it does mean that our image processing algorithms manage to make our AI think the image is very good. We have two recommendations for future studies. One is a similar study could be conducted where the convolutional neural network is trained by a dataset which has one class as images taken by amateurs and another class that consists of the same images that have been enhanced by professional photographers. So pre-processing on the one hand and post-processing on the other hand. Another potential future study would be to maybe examine how the order of image processing algorithms being applied changes the outcome. Is there a more efficient way of ordering the operations? And if there is a more efficient way, how do we do it in the most efficient way?